Many low-level programmers don't know about null terminators. I'm not even joking, and it's actually surprised me because, like, how can you be low level? Like, how can you literally program in low-level languages, but you don't know what a null terminator is? Well, maybe for programmed in like assembly, you definitely knew what it is, but if you program like C, C++, like not many people know what a null terminator is. I'm not even joking. That surprises me. So I'm just gonna talk about it. So basically, to put it simply, right? You have a random string, right? Hello world, and you want to print this string, all right? But to do that, you most likely need to, know the length of the string. So over here we're gonna make our own printf, right? And basically we are going to pass a pointer, right? So basically an address. We can do something like this, but let's say we are using a variable. Basically we are passing the address of the first character over here. We are passing an array if you watched the last video. So what happens if we print this, right? Okay, so now let's try running it. So basically if you run this, then we can see that it prints age, which is actually correct, But how does it, print the whole string? Many people might think maybe iterating the length, so we are size the length, right? And over here we input in a 3. And now we can do, there you go. And you're just gonna put the character into the terminator, right? Let's just do it this way, right? And you should print hey now. Oh, need to do it this way. So there we go. But there has to be another way. Like, what if we don't want to pass in your the length? Like, how can the actual printf function just require, a string? Right? Like, how can it not require a size? And this is how the null terminator comes in. So basically, if we check out an array of strings, right? And now let's try printing a character. Let's try printing the first character. And it's normally going to print H, right? So there you go. But obviously if you do 1, then it's gonna be A, and then if we do 2, then it's gonna be Y. But what if we do 3? Well, no error. So there is another character inside of this string which we don't know about. What about 4? 4, it doesn't work. So there is another character. Let's start printing it. It doesn't print anything. So maybe we can check out the ASCII table, right? So let's get it and let's see what it prints. So it prints 0. So let's check it out. So 0 is an actual symbol and it's called null character or also null terminator. And basically what this is used for is it points, basically it is always put at the end of a string and it is used to calculate the length, right? And we can do so by doing like, let's do int string, right? And it's gonna take you near a string. So basically we know that in C we don't have a true or false, all right? We have for true we have 1 and for false we have 0. So basically when you do like a while loop, this is while1, it's gonna be equal to while true, right? And when we do while 0, it's gonna be the same as while false. So let's try the referencing, right? So this will print over to age, all right, which is completely normal. Like, let's do printf this do actually like this, and then through len through, and over here my printf string. So this normally will print 0, or will it? It actually doesn't, it actually doesn't do anything because it repeats infinitely. Because if we dereference it, right, then it will get the character, which is age. In a computer, everything is a number. This age is actually a number that the computer takes it, like, the computer takes it as a number, but we see it as a letter. So you can check out the ASCII table, and you can see that age is 72, right? So while 72 basically, it's not 0, so we can basically take it as true. So it's gonna do something over here. Let's try doing. Let's go to the next address, right? And let's also make the length one more. And basically now it's gonna go over to the next address, which is gonna be a lowercase, obviously, which is 101. So then it's gonna repeat it, and then we're gonna have y, which is 121. It's gonna do the same thing, go to the next address, make the length 1. And then we can check out next address, which is nothing. But as we've seen before, over here, there is actually a 0, which is the null terminator. Basically, we are doing while 0. So we're basically doing while false. So it's just gonna skip it now, alright? It's gonna enter while loop, and it's gonna return the length. So this will return 3. There you go. So now we can use the same logic over here, and we can actually put the character over here into the terminal, right? And this is basically a mini version of printf. It doesn't actually support like formatting and stuff like that, but it can print normal strings, as you can see. And this is shown better when you're actually using assembly, right? So over here, I'm making an assembly project. For context, as I said in my last video, I am going to use NASM syntax. As I said in the last video, air data stands for raw data, which stands for read-only data, which is basically data that we can't modify, we can just read from it. Basically, in assembly, DB stands for define byte, and it's used when you're defining like bytes, data, and you're gonna want to define this byte. A byte is 8 bits, and it goes up to 255 if I remember right, and it is perfect for characters because, as you can see, the ASCII table goes over to 255. So like this, we can define basically any character there is. Let's do A. And now let's try normally printing it, right? So I have my basically standard library over here, which we will need for this. Normally I have it over to another folder, but to analyze it better, I put it into the same project. So I'm just gonna include it now. So this is a simple program that will print string, and it will print a string, which is hey, and then it will simply return 0. Keep in mind that I'm using Windows, so this is also the Windows naming convention, just because I'm used to it, so my library also uses it, also to keep it, consistent. But when we run this, there will be an error. So let's try running it. I'm just gonna make build.ps1. Oh, wait, I just realized I need to do, that was kind of dumb. But whatever, now it works, definitely. So there we go, it prints, hey, even though it shouldn't. Oh, wait. Yeah, actually, wait. Well, that's kind of weird, but it shouldn't work. Because basically it just repeats it infinite times. Normally, because if we check out stdio and the print function, the first thing that it's gonna do is call the string length function that is inside of std string. And over here, it's gonna have a loop, right? So let's check what this loop does. So basically, string length will take in an address to a string, right? To the start of the string normally. So it's gonna compare the first address. Actually, first it's gonna zero out rocks, the register x, register x, register rocks, rocks, register rocks. It's gonna do RCX, which will contain the address plus 0. So let's say that we have an address 0, right? Or actually 1, which will be, here we have a string k. So this will point to h, right? Then we have a and so on. So basically it's gonna do the address, which will be 1 as of now, plus 0. So it will obviously be still 1. Over here the address 1 is h. Here it references it and it compares it with 0. Here in the ASCII table we can see that h is not 0. So then it's gonna increment rocks, it's gonna add the rocks 1 and then it's gonna go back. Now rocks will be 2. So it's gonna be 1. No, wait, rocks will be 1. So it's gonna do 1 plus 1 because RCX is 1, which since it's the address of the string, and rocks is 1, so it's gonna be 1 plus 1, which as we know is a. And it's gonna compare lowercase a with 0, which is 101. It is not 0, so it's gonna do the same thing. And now we find ourselves with y, same thing. And then it will find if you put an alternator with 0. And as we know, if it compares it to 0, then it's gonna return, right? And it's gonna have in rocks the the length of the string. So I'm not sure why it didn't crash, but whatever. And in NASM, at least, you can put a null terminator by doing comma 0. And in gas, you can do, if I remember right, either asciz or string, right? And in NASM you can also put a new line character with 10. I'm not sure why it's 10 because over here 10 is actually line feed, which I think it actually is a new line character. Wait, line feed. Line feed. Whatever. Yeah, it's a new line character, and in gas, however, you can use simply something like this, just like in the actual languages. But NASM is a little bit better, I guess. Some things maybe. It's a little bit more bare bones also, but whatever. And my asciz string has an actual macro, which is called string, which basically will take a parameter. So here I can do string, and it's gonna be a parameter. And basically, what it does is define byte, the first parameter, and if there is a second parameter, like 10, then it also puts it, and then it also puts 0. So this is basically like doing this, alright? And it should still work. There we go. And yeah, that's kinda pretty much it for, null terminators. Like, I don't know what else to say, to be honest. Like, this is pretty much it. So see you later in the next video. And if you didn't watch my arrays video, my video about arrays, because I guarantee you that you do not know how arrays work. But maybe you do, but most of the times, like, people don't know how it works. So yeah, watch it.